This is A-Level Mathematics Paper 1 for year 2013, question 6. Relative to an origin, the three position vectors of points A, B, and C are given here. So that gives you the position vector of the 3 points. For part A, you are asked to show that vector OA is perpendicular to vector OC. Vector A is perpendicular to vector B if and only if their dot product is 0. To show that vector OA is perpendicular to vector OC, you need to show that the dot product of vector OA and vector OC is 0. So we find the dot product of vector OA and vector OC. Vector OA has components 1, 2p, and q. And vector OC has components negative 4p squared plus q squared, 2p, and q. So the dot product of these two vectors would be the sum of the products of the corresponding components. So you multiply the components of vector I, that gives you 1 times negative 4 p squared plus q squared. That gives you negative 4p squared plus q squared as the product of the components of vector I. The components of vector J, you will have the product of 2p and 2p, which results in 4p squared. And the product of components of vector K, you will have the product of q and q, which is q squared. So simplify the above line. You have negative 4p squared minus q squared plus 4p squared plus q squared. This results in a 0. Since the dot product of vector OA and vector OC is 0, we can say that vector OA is perpendicular to vector OC. For part 2, we need to find the magnitude of vector CA in terms of P and Q. So to find the magnitude of vector CA, you need to find vector CA first, and that is given by vector OA minus vector OC. Always remember that if the terminal point is point A, you have OA first, then you subtract OC. In component form, vector OA is 1, 2p, and q. Vector OC is given by minus 4p squared plus q squared. And you also have 2p and q. So we subtract the corresponding components to find vector CA. So this gives 1 plus 4p squared plus q squared for the components of vector I. For the component of J, you have 2p subtracted by 2p, which gives a 0. Similarly, for the component of vector K, you get a 0. Then the magnitude of vector CA. Since components of J and K are both 0, then the magnitude of vector CA is just the I component, which is 1 plus 4p squared plus q squared. That gives the magnitude of vector CA. For the third part, you are given that P is 3 and Q is 2. So you are given that P is 3 and you are given that Q is 2 here. You need to find the unit vector that is parallel to vector BA. So we need to find vector BA when P is 3 and Q is 2. It's easier to just substitute first and just work with numbers. So over here, you see that vector OA, when P is 3 and Q is 2, you have component 1. Component of J is 2P, which gives you a 6. Component of K is Q, which is 2. That is vector OA and vector OB. Vector OB there is no I component, indicating that the first component is 0. And Q is 2. The K component is negative 2P, which is negative 6. So you have vector OB. Now to find a unit vector that is parallel to vector BA, you need to find vector BA, and then you convert the magnitude of vector BA into 1. And that gives you a unit vector of vector BA, which is parallel to vector BA. So vector BA is given by vector OA minus vector OB. So vector OA is 1, 6, and 2, and vector OB is 0, 2, negative 6. Then vector BA is 1, 4, and 2 plus 6, which is an 8 here. So you have 1, 4, and 8. Let's find the magnitude of vector BA. The magnitude of vector BA is the positive square root of the sum of squares of each component. So that gives you a value of square root of 81, which is 9 units here. That is the magnitude of vector BA. A unit vector that is parallel to vector BA. That would be the unit vector of vector BA itself. So you have vector BA divided by its own magnitude. You can write this as 1 over 9, and the components are 1, 4, 8. So this can be written as 1 over 9, 4 over 9, and 8 over 9. And that is a unit vector that is parallel to vector BA.